I was 6 years old, my mother noticed a little brown spot appear on the side of my knee. I thought nothing of it, but she insisted that it was growing bigger, while I insisted that she was getting crazier. Nevertheless, she took me to see a doctor, and I remember him using a lot of words that I didn't really understand, such as mole and melanoma and surgery, and one word that I will never forget hearing him say is the word cancer. Luckily for me, that was the last I ever even had to think about that word, as I underwent a successful surgery to remove that tiny little dot. In my experience, I only ever had to brush past that word, that taboo word that every day diagnoses up to 51 New Zealanders. The word that accounts for up to 30% of deaths in this country. Whether you've experienced it yourself, known someone close to or distant from you who has, or even just had a tiny little dot appear on the side of your knee, every single New Zealander has had at least some form of an experience with cancer. But don't worry, our spectacular scientists are working on this tirelessly. And recently, an ingenious Kiwi idea was recognized by the globally renowned scientific journal Science as the breakthrough of the year. Imagine that, little old New Zealand on the forefront of scientific discovery. Well, that is where we are, and that is where we will stay. Ladies and gentlemen, let me introduce you to the phenomenon that is cancer immunotherapy, a type of treatment research that is being carried out here in New Zealand as our part for the fight against cancer. Cancer is the name given to a similar group of diseases where basically some of the body's cells begin unusually dividing without stopping. This consistent formation of extra cells can result in growths, known as tumours. Because cancer cells are less specialised than normal cells are, the replacement of normal cells with cancer cells can mean that the cell responsibilities of those normal cells will not be enacted, and this can be incredibly harmful. The immune system is a network of cells and organs that help to protect the body against foreign toxins. It is responsible for the production of white blood cells, a type of defender cell that is made in large quantities within the bone marrow. White blood cells, known as T cells and B cells, provide resistance against more harmful diseases, as these cells are capable of a more powerful defense. Dendritic cells are immune cells that make up less than 1% of a person's white blood cell count. The dendritic cell's purpose is to survey the cellular environment, and once foreign bacteria has been detected, it will travel through the lymphatic system to stimulate an immune response through the T cells and B cells. These immune defenses are so efficient at what they do, considering we're healthy more often than we are sick. So why would we disregard such an effective system? Cancer immunotherapy research involves enhancing these existing abilities of our immune defenses. It is used to provide them with the ability to set out and destroy cancer cells as they appear, rather than offhandedly trying to kill them off ourselves. At the Mulligan Institute of Medical Research, here in Wellington, our very own scientists, led by Professor Ian Herman, are discovering how these responses can be manipulated to deliver an effective response against cancer. Specifically, they are focusing on a form of treatment for melanoma through the use of a vaccine that encompasses these existing strengths of the immune system. For the immune system's response to be considered effective, there are two things that need to happen. Firstly, the cancer-fighting T cells need to recognize the tumour, and then they must be supported to mount a big enough immune response to destroy it. Researchers have found that within a test tube, they are able to, in a sense, educate dendritic cells to develop an immune opinion on certain toxins. This information has inspired the next stages of the development of the vaccine. In the initial stages of the vaccine, while researchers were able to find that dendritic cells were successfully able to locate cancer cells where they appeared, they were not so successful at mounting a significant enough immune response to destroy it. However, a discovery into a glycolipid has allowed researchers to develop a new synthetic product based off of that glycolipid known as alpha-galactosyl-ceramide, which seems to be able to overcome this problem. Alpha-galactosyl-ceramide is a compound found in marine sponges, which was found to have potential anti-tumour activity, but failed to show clinical benefits in patients. However, a group of international scientists, including some from the Mulligan Institute, were able to identify its potential to act as an immune adjuvant, something that could be used to boost the stimulation of an immune response. In an updated version of the vaccine, the adjuvant alpha-galactosyl-ceramide is mixed with dendritic cells extracted from the patient's blood and with synthetic protein fragments common to melanoma. The mixture is then left in the laboratory for a few days, which gives the dendritic cells enough time to gather information about the synthetic melanoma fragments. Then, the solution is injected into the tumour of a patient. Within the body, the dendritic cells will locate the residing area of the T cells and pass on the information they have gathered about the presence of the melanoma. The adjuvant alpha-galactosyl-ceramide ensures the maximum activation of the T cells. The T cells are then able to set out, target, and abolish the quickly dividing cancer cells while still leaving normal cells intact. Behind me, you can see a video of this happening. The green blobs are the cancer-fighting T cells, while the red ones are the cancer cells. When we see the red cell flash, what we are seeing is that T cell destroying that cancer cell. The Institute hopes that this vaccine will be unlike any other form of cancer treatment, that the effect will hopefully cause long-lasting immunity, and as a result, will be able to cure patients as opposed to delaying the disease, as is common today. Globally, some forms of immunotherapy are already being practiced, and doctors are seeing encouraging results, with patients seeming to be going into long-term remission. Practices like immunotherapy are causing international shifts in the way we think about cancer. From this work, we can see that cancer is becoming less like a death sentence and more like a curable chronic disease. And if immunotherapy is able to cure it, then we can easily lessen the social and environmental burdens that come with constant treatments. And treatments used today, such as chemotherapy, radiation, or surgery, all require resources, commitment, and time. But immunotherapy promises positive results at an efficient rate and is unlikely to require constant treatments. As well as this, if the Institute is able to successfully develop a marketable vaccine, we could potentially see huge economic benefits for our country. This giant Kiwi science project could provide New Zealand with a valid product to put on the national or international market. And the Mulligan Institute is doing as much as they possibly can to maximise these economic rewards. Developing a miracle-making cancer cure is not at all an easy task, but the Institute is committed to refining the vaccine through extensive trials, intending to yield the best possible results. And if investment into the vaccine is sufficiently supported, it could become available to a wider range of people. As of now, there are so many options for the Institute to take regarding the efficiency of the vaccine. Research into how the vaccine might work alongside other drugs, into how dendritic cells provide long-lasting immunity, and into a new completely synthetic drug are all taking place alongside the clinical trials of the original vaccine. Right now, probably as we speak, while it is unsure when the vaccine will be released, some researchers are confident that it could be within the next decade. It's truly incredible what passion, curiosity, and a healthy dose of Kiwi ingenuity can achieve. Every year, Kiwis run the Relay for Life. We tie a pink ribbon to our shirt and pin a daffodil to our chest, all to support our Kiwi scientists and their Kiwi scientific discoveries. It's Kiwis helping Kiwis helping Kiwis. Cancer could happen to anyone. But it is our passion for each other and our pride in our country that will help us get past that. And who knows, maybe one day we won't just be little old New Zealand anymore. Maybe we will be the nation responsible for the redundancy of the word cancer. Thank you.
Thanks, Dinithi. I was hoping somebody was going to bring a miracle cancer cure to the party. Is this specific, as far as you know, to melanoma?
No, so already the Mulligan Institute themselves are already practicing research into other forms of cancer, such as brain cancer and leukemia, and they're finding that even the adjuvant alpha-galactosyl-ceramide might actually be able to assist with research for these specific cancers as well. However, while the theoretical aspects of it must be similar, there probably will be slight changes due to the specificity of each cancer.
If your product, Alpha G, I'll call it, if you don't mind, if this is so effective, why don't we all take it now in order to boost our immune systems?
Well, right now it's still under clinical trials, so they're still fully researching into the effectiveness of it and the safety of it. So it is quite a recent discovery, and so for it to be enforced, it has to go under screening to see how efficient it actually is and how safe it actually is for our community.
Any indication of side effects at this point?
Well, like most vaccines, this immunotherapy can induce flu-like symptoms, and so that's the stage that the Mulligan Institute are at now, is just refining, trying to minimise the risk of those side effects from occurring. So.
And how widespread are the materials that you require to make alpha G?
I'm not sure, actually. That's a question that that you could probably ask the Mulligan Institute. However, I know that the discovery of it was made in Japan by a pharmaceutical company in Japan called Kirin, and so they from that information we can assume that it might be something that is available for most of the world.
So you could anticipate that not only people with cancer would have this, but people could have it in order to prevent cancer?
Yeah, well, prevent cancer. Well, that's the dendritic cells are actually the component that could prevent cancer from reoccurring. So after the immunotherapy process, the alpha-galactosylceramide, it's more of something that just boosts the T cells, and the dendritic cells are the ones that prevent the cancer from reoccurring in the patient.
Thank you.
Thank you very much.